Complete the truth table to determine whether the negation of P implies Q is P and the negation of Q. So let's first start here. We want to negate Q. So the negation of true here for Q is false. The negation of false here is that's going to be true. Now we need to find P and the negation of Q. Now remember, when you're looking at and, if one of them is false, then it's false. So we have P, which is true, the negation of Q is false, therefore this is false. Now for P, which is true, and the negation of Q is true, that means that this is true. Okay, now we have P implies Q. So it is false for whenever P is true and Q is false, and then it's true otherwise. So therefore it's going to be false here, and we know it's going to be true. So true implies true. Okay, now we want to negate this column. So we're going to negate P implies Q. If we negate P implies Q, this is true, therefore this is going to be false. Now if we negate this false, then that's going to become true. Let's check our result. There's our answer. Now let's complete the table. Now again, we're going to negate Q. So the negation of true is false. The negation of false here is true. Now it says P and negation Q, P and the negation of Q. That means that if one of them is false, then it's going to be false. So we have a false here for P and a false here for negation Q, therefore it's false. We have a false here and then a true here, therefore it's false. Now P implies Q, it's only false when it's true and false, so that means that these are going to be true. And now we're going to negate this column. So therefore, if this is true, then this becomes false because we're negating this column. If this is true, then that's also going to be false. Let's check our result, and then there's our answer. Now we need to determine whether the negation of P implies Q, which is this column, is logically, or is, so the negation of P implies Q is the following statement. Now the statements negation P implies Q and P and negation of Q, we want to find out whether they are logically equivalent or not. Well, if you look here, we have false, true, false, false, and over here we have false, true, false, false. So that means that they are logically equivalent because their truth values are the same for every possible combination of truth values for P and Q. So this means the negation of P implies Q is P and the negation of Q.